And we let us start, okay. And so let's start here. So today we will start another new data structure. It's about key value pair. And this is quite used quite a lot, okay, kind of data structure, okay, key value pair. And in Java, we call it map, okay, we call it map. And a lot of time, this key value pair kind of data structure and also has a name called associate array. Okay, so they can also be called associate array. And in Java, it's called map, okay. And in C++, I believe it's also called map, okay. And but in Python or C#, they are called dictionary. Okay, Python is dictionary. Okay, and let's see what is the other name. Map, associated array, dictionary, and JavaScript. JavaScript, it's also called JavaScript. JavaScript, I believe it's also called map. Okay, it's also called map. And for TypeScript, I believe it's called dictionary. Okay, and in Python dictionary, it's just a dict. Okay, so anyway, it's regarding key value pair. So previously, all data structure that we learned, they just store whatever, some single object. That, so each item is just one item, okay? And here, it's not a single one, it's a pair. That is a pair. So it has key part. It also has the value part. Okay, the key part and the value part. And if you see, and I think this is the best name called dictionary, is it? So just think about the dictionary, is it? So dictionary is arranged by word, is it? And then it's explanation. Is it word and its explanations or descriptions? Okay, so in this kind of case, the word is considered as key, is it? And the explanatory descriptions, they are considered as values. Regarding that key, is it regarding that key? And another good example may be like address book, is it? Address book, or like a phone book, or yellow book, okay? But a lot of you may not too familiar with phone book. And so anyway, like a yellow book. That it's arranged by, so you have name, is it? And then they are like a phone number, address, something, is it? So in that regarding, name is key, is it? And the phone number and address and related information, they are considered as value, okay, as value. Okay, so this is the general idea. And also generally speaking, key should be unique. Okay, it's and over here we will see it's not what we mean here unique is when you do hashing. Okay, later on we will also learn when you do hashing, the hashing value should be a unique one. Okay, to avoid some collision. Okay, so this is just a general requirement, but in the application, we will see a lot of time. We will have a lot of collision, but how do we handle it? Okay. So anyway, so it's a key value pair. It's a key value pair, and because of it's arranged as key value pair. Is it? And then just think about whenever you use dictionary. Just think about whenever you use a dictionary, how do you do lookup? Is it? And regarding lookup, we mean like a search. Is it a search? And for search, like for other data structure, is it like a list? Is it list or array? Is it? And or even we already learned like a binary search tree. Is it? And for list, then you need to do linear. Is it? So it is linear. So order of n. Is it? Even for array, it's order of n. And binary search tree, then it's what? It's order of log 2n. Is it? But it still involves you kind of need to do 1 by 1 comparison. Is it? And for dictionary, if you recall, how do you use a dictionary whenever you do lookup? You are not going to start from the beginning of the dictionary and search every single one to find it. Is it? You just look up that word. Is it? And then you find the result. Is it? Find the result. So generally speaking, with this kind of key value pair, when you do lookup, the lookup can be order of 1. Okay, order of 1. But of course, later on, we will also see it depends on the implementation. Okay, implementation. And if you want to achieve order of 1 time complexity for lookup, then it involves the concept of hashing. Okay, if we use a hashing, then we can quickly locate where the item is. Okay, where the item is. Okay, and we discussed the time complexity here. So how about let's do the first quiz question. Quiz question, order of 1 represent what? Represent what kind of time complexity? Order
constant.
Of constant, yes, very good. Okay, so this is constant, okay, time complexity. Okay, so time complexity, is it? So then for the lookup for the dictionary, it's constant. Then compare with list and the binary search tree, or even including array, is which one is the best here? Just regarding the lookup. So how about this is going to be the second quiz question.
Hashing.
Which one? Excuse me, can you repeat?
Hashing.
Sandra, you said the hashing complexity is 01.
Yeah, so here I want you to answer among the different kind of data structure list array and plus the map. Among what we list here, then which one is the best?
Map.
Map, okay. So map is the fastest, is it? Okay, so basically that's the feature. Okay, that's why we use map. Okay, so it's very quick to do lookup. Okay, to do lookup. Okay, and this kind of concept is kind of like array, is it? Array, you have index, and if you know the index, you can quickly locate it, is it? So if you use the index, then the accessibility is also order of 1 if you use index, is it? Okay, so that's the feature, okay, for map. So this is lookup, okay. Generally speaking, if using hashing, it's just general, okay, not always, okay. It's going to be order of 1, so constant time. Okay, constant time. Okay, so that's regarding map, general conceptual concept, okay. And in Java, we already learned that Java has the collection framework, and previously we learned under a collection, and the collection is an interface, and you can have queue, and we can also have list, and we also have what? A set, and under set, we have 2 different. So set is this all interface, is it? And under set we have hash set, is it? And we also have sorted set. And then we have navigable set. And from it, we have the tree set. Is it? And for hash set, we also then have linked hash set. Is it? And but anyway, set, list, queue, they all belong to collection interface. Okay, but be careful. Okay, map doesn't belong to collection interface. Okay, map is its own. Okay, so if you draw the hierarchy, map doesn't belong to collection. Okay, so under map, it's an interface also. Okay, it's kind of similar like set. Okay, it has 2. It has a hash map. It also has sorted map, and the navigable map and the tree map. Okay, and it also has a linked hash map. Okay, so that's the general arrangement. But be careful. Okay, map is not a sub interface of collection. Okay, it's its own. Okay, it's its own. And the map, each map item has 2 parts, the key part and the value part. It's key value pair. Okay, also keep that in mind. It's different from queue, list, and set concept. They only have a single item. It doesn't have key or value differentiation. Okay. So anyway, so because of that, is that for generic representation, when you write a map, then for the angle brackets, that's why you have 2 generic, key and value. Okay, key value. So the type of parameters at the key is the type of key maintained by the map. Is a V, then it's the value. Key value can be different. That can be different. Okay, and this is regarding the general idea about map. Okay, map. Then let's take a look over here. The more explanation about map. Okay, and the map is that an object maps keys to value. We already explained. So it has two parts. It's a key and then value. That generally we write as a key value pair. It's a key value pair. And generally speaking, is that key doesn't, or map doesn't contain duplicate keys. Okay. And each key map at most one value. Okay. So the interface, okay, the interface is, map is an interface, and we also say a dictionary, etc. And it says map interface provides us three collection views. Okay, three collection views. So be careful here. Okay, so it provides its view, its collection view. Okay, collection view. So what is that? You have key, is it? And the key is unique, is it? So if you have multiple map items, then all of their key together will be what? A set of keys. So that's why here, this set of key is a collection view. Is it? And it's the type is what? Is set. Okay, and it also has collection of values. The type of this is what? This is K and this is V, is a type. And what? And the key value mapping. Okay, it also has something like this, the key value mapping. The key value mapping later on we will say it's called some entry. Okay, map data entry. Okay, so entry is key value mapping. Okay, so that's the concept part. Okay, and the map, it's, if you recall, for previously all we learned, like queue interface, list interface, etc., and the tree interface, they are ordered. Is it ordered? Certain order, either insertion order, is it, or some other order? That depends, is it? And the set, we learned, it can be unordered, is it? And it can also be ordered. Is it ordered? Okay, and then how about let's do the, this is the second quiz question, is it? Second.
Third quiz question.
Oh, third quiz question, sorry. Thank you. Third quiz question. Regarding set, as we discussed, that it can be unordered, it can be ordered. So regarding unordered, what are the two what are the unordered one? Is it unordered one? And for ordered, what's the name for ordered? Regarding, how about let's just regarding the concrete class.
Do you mean hash set?
Yes, yeah, unordered is hash set, is it? And for ordered is what? Two kinds of order, is that whenever we discuss order. Some we can consider as insertion order, is it? Or like list access order. Is it? And we can also ascending order or descending order, something like that. Is it? And what are those two? Who still remember? Ascending or descending order is what? The tree set. Is it? Insertion is a what? Linked hash set. Is it? Okay, so that's regarding set. Is it generally speaking, in math, whenever you draw set, it's just a pie. Then you just drop everything. Is it in the set? So it's unordered. Is it? Okay, and then map. Okay, map here is that the order of map is that it's defined as the order in which iterator of the map's collection view return. Is it return? And it says some map implementation, like a tree map, it has guarantee. Is it? But for hash map, then it doesn't. So this is a similar concept, okay, as set, okay. So for map, we can have a hash map. Then it's unordered. Okay, and if you want to have, then it's tree map. Then it's ordered. And we also see it also has linked hash map. Okay, linked hash map. Okay, and so this is regarding map, the order. Okay. Then next it's state here, the official document. It's a great care must be exercised if mutable object used as map keys. Okay, as keys. And generally speaking, and if you learn Python, is it for Python, the dictionary, the key must be immutable. Okay, must be immutable. Okay, but here in Java, it didn't specify it's must be immutable. Okay, immutable. But because it involves a hashing, is it? And so it must meet a certain definition of the data equal. And later on, we will see the hash code method. Okay, the results must be consistent with that. Okay, so this is regarding a map, and you can read in more detail, okay, about the map. And here we also, it also says that a hash map here, sorted map, okay. Okay, and then next, let's see. So map, and later on we will also see in our application, okay. So for map, it has a nested class. Okay, nested class called entry. Okay, it's map entry, okay. And previously we see that map is not collection. So be careful, okay. We said it's a collection, hierarchy, is it has its hierarchy, and the map is its own independent, is it? But map has collection view, collection views. Is it? The view is what? Is the set of keys. Is it? Set of values. Okay, and the entry, set of entries. So here is regarding the entry. Okay, and it's a map, the map entry. So it contains both key and value part. Okay, and it's defined as a nested class within the map interface. Okay, Okay, so this is regarding general idea about map, and it has some method. Is a clear method? Okay, it's very straightforward. And the compute later on we will see. Okay, and for compute you can see it has the first parameter is just key, and what is this? The second is some bifunction. Is it? So it's some functional interface. So this is some functional interface. Okay, functional interface. And the computer is similar. There's some, those are all functional interface. Okay, and basically this is the lookup, contains case, is it? And contains values, is it? And for map, if you want to get all of its entry, is it the entry? And you can return it as a set of entry. Okay, so it's through this method called entry set. Okay, so it's a set view. Okay, set view, but the type of the set is the entry. And the entry is within the map interface. It's a nested class, okay? And the equals method, get method for each as usual, is it? And we will also see get key, is it? So what this will get, it returns the value. Is it? You provide a key to return the value, is it? And what does this mean? The get or default, is it? So maybe the key, so if key does exist, if key does exist, it will return the value. If not exist, then it will return the default value. That's what this part means. Okay, hash code later on we will learn. And it is empty, nothing new here, is it? And the key set and the merge we will also see. Okay. And the put. So whenever you want to add a new key value pair, you call put. Okay, so this is to add a new key value pair. Okay. And the method put all, is that you can also hear what it says is copy off the mapping from some specify, from some existing mapping, is it? Some other mapping. And put if absent, is it? So that's also if it doesn't exist, then you can provide some null value, is it? And remove a key, is it? And remove key value pair. And you can also do replace size. You can also get all of the values. Is it what it return some collection. Okay, so we kind of get some idea, is it, about the map. Okay, about the map. And then let's see about the map. Okay, so generally speaking, so we already understand the key concept for map is key value pair. The key value pair. Okay, and then how do you implement the map data structure? Is it like previously we also discussed? Is it like linked list? Is it linked list? You use node and then you link them together. Is it? That's the implementation. And for binary tree, and we use binary node, is a bin node, and then you link them together. Is it? So that's the tree linked way implementation. Is it? And we can also implement some other data structure, is it? Like a stack, you can using array to implement, is it? And the queue. And of course, you can also implement a stack and the queue, also using linked way to implement, is it? Basically in Java queue, whenever we want to use queue, we call linked list, is it? So it's a linked implementation. So then similar concept, is it, for map, is it? Map, when we consider its implementation, how do we implement it? Is it? So there are a couple of ways you can implement, is it? And one is you implement as a using hashing approach to implement. Is it the hashing approach to implement? So the concept is, if you recall previously, when we learn linked list, one of the lab is regarding you implement using some hash table. Is it, you recall, the hash table is you have an array of linked list. Is it array of linked list? So so kind of, so this is sub 0, is it? Then it's a linked list. Is it? And sub 1, you have a linked list. Is it? And till like sub 10, is it? And if you recall that lab, is it? So we have an array of linked list, and then you have some word. You have some word, is it? Some string, is it? And then you want to store in one of the linked list, is it? And what we do is we do some hash function. And that hash function is pretty simple, is it? You just use the ASCII code of the first 3 letters, is it? And then you module 11 or module 13, is it? And because you do module, the result will always be 0, 1 to 10, one of it, is it? When you get it, and then you can insert it add it to the linked list. Is it added to the link? And then whenever you have a new word coming, is it, if you want to do search hello. Search hello, how do we search it? You're going to apply the hash function. So find the addition of the first 3 letters ASCII code, and then module 11 or 13, as it depends on what you choose. And then you find, suppose the module 11 is, suppose it's 5, is it? Then you will directly go to the 6th linked list to find it. Is it? To find the hello, is it, where it is it? So this concept is called you using hashing approach to do the implementation. Is it implementation? And just think about, if you're using hashing, and if you don't use a linked list, and each one just matching one item, then definitely this can guarantee order of 1. Is it? Because each one just map exactly one result. So that's why you don't need to do 1 by 1 comparison to find the result. You just do the hashing, and then you directly locate it. So here the concept is kind of using hash table as a concept. Okay, so this is one way of the implementation. is it? And the other way you can use is the second way. The implementation is you can implement using balanced binary search tree. Is a binary search tree. And then in this case, then we can guarantee order of log 2n. Okay, but it's a balanced. Okay, so that's why we can guarantee it's order of log 2n. Okay, so it's not going to using hashing. Okay, and your binary tree is going to store all of the keys. Is it all of the keys and the key, the entries? Is it the entries? So this is the second way. Okay, the second way. Okay, regarding the implementation. That's we kind of have general idea, and then let's go ahead, take a look at an example. Okay. Before we go to the example, first let's take a look at what our textbook discussed. Okay. Okay, the textbook, the map interface, we already kind of have a bigger picture, is it? So you have the key, and generally speaking, like over here, it's draw. The key is for search key, is it? Search key, and the map has two parts: the key part and the value part, is it? Just like you have social security number as a key and the person's name as the value part. Okay, and in Java, I said map can be any objects. Okay, any objects. Okay, so this is regarding general concept about a map. Okay, and for map, the hierarchy of map. Okay, and like I said, at the very top, it's a map interface. Okay, then it has sorted map, navigable map. It's similar as sort or set. Okay, and the tree map is concrete class. Similar as a hash map and linked hash map. Okay, and both hash map linked are based on the abstract map, abstract class. So anyway, so this is the hierarchy, okay, of map. And we already saw this, okay, the map interface in quite detail. And over here, it shows about the concrete map class, is it? So we have the hash map, okay, linked hash map, is it? And here we have the tree map, is it? And tree map, it's from both the sorted map and as well as the abstract map. So it owns the feature from both interface, okay? And then regarding that nested class entry, is it in Java's map class? So entry to provides get key, get value, and also set value. Okay, those three method. Okay, and then hash metric, it's similar, pretty similar as set, but it's just a linked hash map. Okay, and then let's take a look at our example. Oh, I needed to do the share screen. Okay, so here comes our example. And in this example, it's similar as our set example. And we are going to have create a collection map of books. Okay, so we are still going to use the book class. The book has ID and name. Okay, as that set example, and the book has get ID, get name, set clone method to string equals, and it also has a comparator class implemented. Okay, So not a lot of new things here. And then let's get to the map, okay? And to use map over here, you need to import the map interface. And we are also going to use a hash map, linked hash map. So you need to import that, okay? And the tree map, because we are also going to use set and the collection. So we also import both of those two packages. So let's take a look at what we did here, okay? And this part is similar. So the starting here, we create a hash map. Okay, so here we first create a hash map object. And that with this hash map, the key is integer and the value is book. Okay, so integer and book. So that's the key and the value pairs type. Okay, be careful. So this is key and this is value, the type. And the map has, has a pair of items associated with it. And then here we have 8 book be stored in an array, okay? So as in the previous year, create a bunch of books. And then how do we add? So we are going to loop through the array. So this is loop through array. Is it? And then we are going to add one by one to the map. Is it to the map? And the map is integer, so using ID and the book. Is it? So that's why we get each book's ID as a key and the book. Okay, and the book. And then if you want to output each book, is it each of the map, is it? Then you can call map itself has a for each method. Okay, be careful, okay, within this for each, then you have key value. Is it? So this is the key and this is the value. Okay, and then it will automatically get each of its key and its value and output it. Is it? And this for each, you can see it also takes in some functional interface object. Is it? So some object of a functional interface. Okay. Okay, so we can kind of run to take a look what it looks like. And the adding sequence looks like we had 111, 131, like a kind this sequence, is it? And we can take a look to see. And if you take a look, the result, it's not arranged as your insertion order. Is it? It's some other random order. Is it? So not the same order as your insertion, okay? Okay, and then next, let's see. And if you want to search some item, look up, is it? Then you can just call, and using the key, is it? So you can call contains key. Is it? Oh, this contains, I'm sorry. This contains key is just to see if the key is in the map. Is it? So it will return true, false. Okay, true, false. And if you want to get value related with the key, then you can call get method. Okay, but anyway, all of this involves lookup. Is it contains get and it contains value, is it? And let's take a look at the contain value part. And also, did you see for the contain value part, it's not looking for the reference, it's just the copy of the value, okay? So it's a copy, okay? So it's not the reference, not need to be reference. Okay, in this case, okay, because internally to use that data equals to check, okay. And we can also see this get or default, etc. And I want to see if it has this item. If it is not, then it will just use this, is it? And we can take a look at the running result. Okay, the contains, so it does exist, is it? And it can give you the value part, is it? And it does has the book, is it? And the book with the specified key is 1,000, as it doesn't exist. So it will provide whatever the default one that you provided in that get or default, okay. Let's get back. And then what next one, if you want to get all of the key, so all keys here, is it? So then you can call maps start key set method, okay. And you need to assign it to what? To a set. And the set type needed to match the key. Okay, and the value, what it returns is a collection. So you can assign it to a collection. Okay, collection. Okay, and we can take a look at the result. Is it all of the key that it return you? And the value. Is it the value are the books? Okay, are the books. And then, next, let's see. Over here, is it? Over here, so this call that compute method, okay. This can be used to update the key value pair in your map, okay, in your map. So you specify key, and you update the value part. Okay, so I want to update the value, okay, with this new one, all capitalized. Is it? So this is on the original reference. You update the reference. Then you assign the reference to the value, then you return the value. Is it? That's how what we did. And here we use the lambda expression. Okay, lambda expression. Okay, then you can update it. Okay, we can update it. And similar here, compute if absent. Okay, you can also use the compute if absent to insert a new key value pair. Okay, so if this key already exists, it won't add. Okay, and if it doesn't, then it's going to be assigned with this new value. Okay, and here be careful for this part, you have key value as the argument. And here you just have the value as argument. Okay, so this is regarding compute if absent. Okay, and what next one try to show is you can also do merge. Okay, do merge. And do merge here says if the key value pair already exists in map, okay, then the lambda expression is going to be used to update. Okay, like in this case, is it 116? You already exist. If it's already exist, so it will not take this part. So it will go to this updating, is it? So old value and new value, is it? And it will be updated with this new value. Okay, new value. That's what this means. And when you do the merge, if you use if the key value is not in the map, then it won't go with this. It will take the second argument. It will create a new one. Okay, create a new one. So that's regarding the compute and merge method, is it? And compute merge. And then what next one try to show, if you recall, for map, it has that entry field. Is it? The entry is a nested class for the map. Is it? And it also has a key value. Is it? And if you want to get all of the entries of the map, then you can call entry set. Is it? And it's a set, returned as a set. And because it's a set, then you can use for each loop. And this loop variable, the type, need to be what? The entry. And whenever you access entry, you need to do map data entry. Okay, and then you can get its key and the value. And this get key, get value is from the entry class. Okay, it's not maps. Okay, map doesn't have get key, get value, it just has get. Okay. Okay, so that's regarding this part. Let's take a look at the corresponding running result. Is it? And if you recall, so this is, we loop through using the entry set. Is it? Set of the entries. Is it? And if you recall, it does update it. Is it? And did you see the key value pair? Is it? So this is merged and this is updated. Is it? So all of those can work with its specified way. Okay. And then next, let's see. So previous is a hash map. Hash map, no order. Is it? But remember, okay, if your application mostly do lookup, okay, and lookup, add and remove, is it? And if you care more about speed, is it? Then you choose the hash. So use a hash map. Use a hash map because generally speaking, it's order of one. Okay, order of one. Okay. And when should you? So here it shows us another one about tree map. Okay, the tree map. So if you care about order, okay, then it's order of log 2n. Okay, when you do lookup. Okay, but you can get the order pretty quickly. There's a lot of other useful information you want to get from the map. Okay, so anyway, so here we initiate a tree map object. The type, you can also use the interface navigable one. And then we add the original hash map. You can call put all, and then this time, let's see the running result. Then did you see it does arrange it in ascending order? Is it? Ascending order. This is a tree map. Tree map, okay. Okay, and then let's see. Then regarding tree map, Is it because of the tree map? Then all of this is going to be useful from navigable map. Is it? You want to get what is the first entry, what is the last entry, is it? And the ceiling and the floor, is it? Okay, so here is that the ceiling, so regarding key, is a regarding key. So lowest key greater than 120. Is it? That lower is greater than. And the floor is highest less than 120. Is it? So you can call. So over here, then you can do comparison with tree map. Is it? With a hash map, you cannot do comparison. Is it? So when you pick an application, you need to decide. Is it? If you want to do some sorting, want to do some comparison, is it? Then probably you better choose a tree map. Okay. And then, so it's not just regarding key, is it? You can also use entry to find it. Is it? To find off the entry here, key greater than, and its corresponding entries. Is it? The corresponding entries. And the similar as higher and lower, as it previously we also learned. And what is the head map, the tail map, and the range, is it? The range of the map. Okay, and you can also rearrange as descending order, is it? And you can also remove with the specified key, okay? So anyway, so here it just shows all of the, so be careful, okay? All of this not available in hash set, okay? Or not, yeah, in hash set. They only available with navigable, not set, hash map, navigable map. Okay, so it's belong to certain features of the corresponding map. So we can take a look at the running result, is it? And so like you see first map, is it? Yeah, it is a first, and the last will be the 223, is it? And it's at the lowest key greater than 120 is 121. Is it? Lowest greater than, so it go all the way, is it? And lowest key and its map, it also gives you the entry of this one, is it? And the highest greater or less than 120, and of course it is this one, is it? You can identify. And also lowest key, is it? And its map, it also give you all this. And here it also give you view of the map less than 120, is it? So then it give you all of this range, is it? So with the tree map, then you can collect all of those kind of comparison and sorting related information, is it? And also here some range, it also gives you, is it? Okay, so that is regarding, and also after you remove, is it? You can also remove it, then it doesn't exist, is it? And you can see the 117 is not, doesn't exist in this map anymore, okay? Okay, so that's regarding that part. And what next one try to show here? Okay, try to show. And if you recall that we can use Java support streaming, is it? Streaming, so Java. But streaming only applies on collection. And the map, so map doesn't have string, okay, because map doesn't belong to the collection hierarchy, is it? But map has what? Map has that entry set. And the map's entry set, it returns as a set. And because it's set, so you can continue using string. Okay, you can continue using string, okay. String method. And with string, basically here, the idea, the concept is we apply functional programming concept. Is it? And like the statement by statement kind of writing, that is called procedure programming. Is it? And even including like OOP, object-oriented programming, is it? It's procedure programming, okay? And this is part of functional programming, okay, functional programming. Okay, and my mouse not working. Sorry, I need to, for some reason why. Hold on, okay, I don't know why my mouse not working. Just keep, hold on, okay, I need to, hold on. For some reason, oh, I'm sorry, that's why. It's not my mouse, it's make it very complicated. Okay, so, so anyway, so let's take a look here, okay. What over here we did, we can then, after you apply the entry set, then you can apply string, okay, with streaming. And streaming here, what we first do? We first do some filtering, is it? And the filtering, what you want to take of the items, you want to get off the key greater than 120, is it? And what this filter returns a string object. Okay, and because it returns string object, so that's why you can chain to call another method called map. Okay, and what do you want to get? Okay, you said I want to get all of the values corresponding to the key, is it? And then for each of it, you are going to output all of the value, okay? So that's what this aggregation streaming does. So let's see the result, okay? The result, did you see? It does give you all of the keys that are greater than 120, is it? And all of the books and output them one by one, okay? Okay, so that's regarding that part. And then the last one I try to shows with the linked hash map. Okay, for the linked hash map, so this time it's based on the original array. Then you're going to add one by one, is it? And then we can take a look, the order. So for the linked hash map, then did you see it, the order as insertion order? Is it the order how you add each of the book, okay? So that's the feature for a linked hash map. So it to keep wherever the order you want to insert, okay? And for the linked hash map, okay, and you can also create linked hash map with access order, okay, access order. And then with specify initial capacity and the load factor, okay, load factor. So here it says, okay, initial capacity is 20. So basically this kind of, you only allow 20 entries. 20 entries. And this is called load factor. Load factor means, so if you add 75% of the 20 entries, then because otherwise it's just like array, that array is fixed size. But over here, you allow it dynamic grow. But because for the efficiency, so initially you let its capacity be just 20. And because here you wanted to do the high, quick indexing, so we use kind of the hash table concept. So the array size kind of 20. But later on, when it reaches 75%, it may think, okay, probably you're going to have 100 entry. Is it? So then in that case, when it reaches to the 75 of that initial capacity, then it will increase the size. The hash table size will be increased. And after its size increase, then all of the hash need to be rehashed. Because for 20, then the hash is from 0 to 19. Is it? And if you increase to 100, then it's going to be 0 to 99. So then the hash need to be rehashed. Okay, rehashed. So anyway, and if you create a linked list with this kind of specification, then it will be created with access order. Okay, okay, so you add all the items, is it? After you add the items, here you call the get. You specify the key. Okay, you specify the key. And because this 211 is the latest accessed. Is it? It's latest accessed. So then it says the map order is updated with the key moved to the last. Okay, so least recently accessed. So the access order is least recently accessed to most recently accessed. Okay, to most recent access. And here, because whenever you add the order as the array order, so it's least recently accessed is at the beginning, most recently accessed at the very back. Is it? But later on, after you access certain of the item from the map, when you try to do the iteration, you will see the original order is also broken, okay? And we can see. Is it the original? This is the original linked hash, is it? So this order is based on array order, is it? And the array's order is least recently accessed to mostly recently accessed. Is it? But then we call get for this specific one. Is it? So then this is updated to what? To most recently accessed. Is it? And when we do the loop, did you see? We access what? I'm sorry. Let's go back. Okay, kind of get messed up. Oh, we access 211. I'm sorry. Okay, we access this. Is it? And then it's changed to what? Most recently accessed. Because it changed to mostly recent access, did you see? It's moved toward the back of the map. Is it? So it's arranged as least recently to most recently accessed. Okay, so be also careful about the linked hash map. Okay, linked hash map. So here is, so the order is based on the least recent to most recently accessed. Okay, so for this example, we are also done. So we kind of